So start with a 2 by 2. Okay. So given A is equal to A, B, C, D, then the inverse of A denoted as this is going to be 1 over the determinant of A multiplied by the adjoint of the matrix A. And how do we find the adjoint of the matrix A? The adjoint of matrix A is you switch these two. So you switch D and then A, and then you change the signs of the minor diagonal. So minus B minus C. So this becomes the adjoint that you pick and plug here. So if I give you an example, all the examples are coming from the cherry sheet. So find the inverse. This is on question 5. Find the inverse of A is equal to 1 minus 3 minus 2, 6. So you say, first thing is to get the determinant of A, which is this, 6 by 1 minus negative 2 by negative 3, you get 6. So this is giving us 0. So if the determinant is 0, then you say A does not have, A does not have the inverse. A does not have the inverse because the determinant of A is equal to 0. So it should not be 0, so I'll be able to divide it here. Otherwise, you have undefined there. Okay. So this was A, and then B. B, let's say the matrix B is equal to 3 minus 2, 4, 7. So you say the inverse of B comes after you have found the determinant. So first we find the determinant. The determinant of B is equal to 3 times 7. Here we get 21 minus 8, which is 21 plus 8, which is equal to 29. And so the inverse of B is equal to 1 over 29 multiplied by, you now go inside, switch 3 and 7, and then negate negative 2 and 4. So this becomes the inverse. That is for a 2 by 2. It's not much, just switch the minor diagonal, I mean the major diagonal, and then change the signs of the minor diagonal. That's a bonus if you're asked to do that. Now let's go to 3 by 3. Okay. Find the inverse of, from question 5, of picked B of A 2, 1, 1, negative 5, negative 3, 0, 1, 1, 1. Now this is negative 1. Okay. To find the inverse of A, the inverse of A is going to be 1 over determinant A multiplied by the adjoint of A. And how do you find the adjoint of A for a 3 by 3? The adjoint of A is a transpose of the cofactor matrix. Adjoint A is equal to the transpose of the cofactor matrix. Adjoint A is equal to the transpose of the cofactor matrix. What is the cofactor matrix? The cofactor matrix are the inner determinants of each entry with respect to the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. So you use these when finding the cofactor matrix without having to multiply by the entry number. So we start here. We first find the determinant of A. So how do you find the determinant of A? You pick either a row or a column. So we'll pick the first row. So we'll pick positive 2 and then remove the column and the row. Then the remaining matrix, you find the determinant. So you say 3 times -1, we get 3 and then minus 0. So we just have 3 there. And then go to the next one. Go to the next one. So there we have 2 by 3, that's just 6 there. So 2 by 3, we found 2 by 3. And then the next one, we come to this one. So you put -1 now. So -1 because of that negative there. Okay, and then remove the column and the row. The matrix remaining 5 times -5 times -1, we get 5 minus 0. So we have 5 minus 0, and then plus 1. Again, you remove the column and remove the row. So you have -5 minus -3. That's -5 plus 3, which is -2. So this comes out to be 6 minus 5 minus 2, which is equal to -1. That's the determinant of A. Then now, after you find that the determinant of A is not equal to 0, then you know this matrix has an inverse. You now find the cofactor matrix. So how do you find the cofactor matrix? So we're now finding the cofactor matrix. Cofactor matrix. So you pick this plus, place it here, and then remove the first column, the first row. The matrix remaining, you get its determinant. So we're interested in the determinant of -3, 0, 1, -1. Now we need determinants of each entry. So we can't have that space of writing all those entries. So what we do? We'll be going straight to getting the determinants without having to write that. But of course we have a plus. And then I do this. So if I want, I can put the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. I have put the signs in advance to avoid forgetting. Then from there, where do I go? I now go and start getting without using, I won't use this 2. I'm just using the inner. Once I pick 2, I remove it. I'm just interested in the sign and then the determinant of the inner matrix. So here I'll have this 3 minus 0. I'm getting 3. So 3 minus 0, we're getting 3. Next, you got 1, second entry, so it has a minus, so you pick the minus, it's already here. So I'm just removing this and that. Then -5 minus 1, I'm now doing this minus that. So -5 minus 1, that's 5 minus 0. So this is 5. Next, I remove this, I remove that. Then I'll have -5 minus -3. That's -5 plus 3, which is -2. Next, I'm now removing this and this. So -1 minus 1, -2. Next, I'm removing this and that. So -2 minus 1, -3. Next, I remove this, I remove this. Then I have 2 minus 1, I get 1. Next, I remove this, I remove this. Whatever remains, I'm getting the determinant of what remains. So 1 by 0 minus -3. So that is 3. Next, I remove this, I remove this. 0 minus -5. So I have +5. Then I remove this, I remove that. -6 minus -5. That's -1. So now we're interested in the transpose of this matrix for us to form the adjoint matrix of A. So the transpose of this matrix, what was to get the transpose? What was a row? You make it a column. So what was a row? You make it a column. So start the first row, become the first column. 3, -5, -2. And then 2, -3, -1. And then 3, -5, -1. Like that. So this is the adjoint. So now the inverse of A is equal to 1 over -1 multiplied by 3, 2, 3, -5, -3, -5, -2, -1, -1. So 1 over -1, that is just -1. Multiply throughout, we get -3, -2, -3. And then 5, 3, 5. And then 2, 1, 1. Like that.
Sir,
Hello.
so in short, you only pick the numbers, those numbers where the lines are crossing when you want to find the determinant. Only when you want to find the inverse, you don't pick them.
When finding the cofactor matrix, you don't pick them. You only pick them when finding the determinant.
Okay.
Mm-hmm.
Okay. Thank you.
Okay.
Yes, sorry. So, sir, during an exam, the way you have done the first step for finding cofactors of the matrix, it's okay even if you didn't show the whole steps for addition.
Yeah. Very okay.
Okay. I think this one saves time.
There's no need of showing. Oh, when are you going to finish? You should do it. Any other question? It should be very easy to find this inverse so that when they say now, okay, since you're able to find the inverse, now use it to solve the system. So, use it to solve a system of come in. Come in. So to use the inverse to solve the system, for example, if you are given a system of matrices, say, example, that was 1, I'll say 2. Solve system of equations below. And what's the system? System is 2x plus y plus z is equal to, let's say 4. And then minus 5x minus 3y is equal to 6. And then x plus y minus z is equal to 8. So they ask us to solve the system using the inverse method. Using the inverse method. So you say, okay, to do that, first thing you write this. You write this in the form ax is equal to z. What do we mean by ax is equal to z? A is the matrix of the coefficients of the left variables. So here you just get 2. Then you get -5, the coefficient of x. Then you get 1 to form the first column. Second column, the coefficient of y. So 1, -3, 1. And then 1. If there's no z, it means this coefficient is 0. And then -1. This multiplied by x, y, z. The variables equal to the one that you're calling z now, we're calling the solutions. You put them in a column like this. So we're saying this is a, this is x, this is z. That's why I've just named them. Or you can name them in any way. But I'm naming them according to this direction. Then from there, you find the inverse of a. So you need to find a inverse. Now the good part is that if you look at this a, it's exactly the a that we have this side. And so its inverse is already here. So the inverse of a is -3, -2, -3. And then 5, 3, 5. And then 2, 1, 1. 2, 1, 1. So meaning if you didn't know what the inverse of a is, you have to go through this procedure. You find the inverse. After finding the inverse, then now you get back to the system and say, oh, so because we know if you multiply a inverse by a, what you get is the identity. And the identity by any matrix, you just get that matrix. This means that to find this, since it is ax, is equal to Z. We'll multiply by A inverse on the left and by A inverse on the left, like that. The left of both. But we know this is the identity. This whole thing here is just giving us X, which is equal to A inverse Z. So we won't be doing that on the left. On the left, we'll just be picking X. So in this case, I'll say, oh, so X is equal to A inverse, which is here, minus 3, 5, 2, minus 2, 3, 1, minus 3, 5, 1. This will multiply by Z. Which Z? This one, the solution matrix, 4, 6, 8. Then what do we get? First to check, are you able to multiply? This is like 3 by 3. Multiplied by 3 by 1. So we can multiply because the inner are equal. So you start negative 3 by 4. We get negative 12. Negative 2 by 6. We get minus 12. Negative 3 by 8. We get minus 24. Again, 5 by 4. 20 plus 18 plus 40. And again, 2 by 4, 8, and plus 6, plus 8. So what
excuse me, sir.
hello?
I'm confused. What's going on? Like, how are we going to find the X and Y and Z variables?
So once we're done multiplying here, whatever we'll get will be the X, Y, Z variable.
But then I'm seeing A inverse multiplied by A. All of those mini equations are confusing me. What are they for?
So the initial equation that we have is the equation AX is giving us Z. This format here. This is what we have as our initial thing from the given system. So you're able to break the system into this format here. Because if you start multiplying, you say 2 times X plus 1 times Y plus 1 times Z. That will form this line. Again, if you start negative 5 times X, negative 3 times Y, 0 times Z, you have this line. So because we're able to retrieve those lines from this, then now we can write this whole system in this form. Once we do that, then we can say, oh, so now we have this equation here. And what is key? We want to find X, Y, Z, meaning we are finding the matrix that we have named X. So from here, we need to make X the subject. Now, because we don't divide in matrices, what we'll do is we'll find a matrix that when you multiply on the left and on the right, it will take away everything else on the left and it will help us make X a subject. How do we find that matrix? You just find the inverse of A, because we know that the inverse of A multiplied by A will give us an identity matrix, which when you multiply by any matrix, you just have that matrix. So because we know that that happens, here we just say X is equal to A inverse multiplied by Z. This is what will give us the variable that we want.
Elsa, does the order matter of multiplying when you're
The order
multiplying the
matters.
inverse there?
The order matters for all matrices. Because if you try Z multiplied by A inverse, it may not work.
Okay.
So the order matters. So here now we have negative 24. I mean negative 12 minus 12. We get negative 24 minus 24. We get negative 48. And then 20 plus 40, 60 plus 18, 78. and then 8 plus 8, 16 plus 6 and 2. So this means that x is equal to negative 48, y is equal to 78, z is equal to 22. So just the way you get them, the first one is x, the second one is y, and the third is z. If they ask you to use the inverse method, you first write your system in this format, and then find the determinant of matrix A, then find the cofactor, and then arrange them in order to find A inverse. After you have A inverse, then you multiply A inverse by Z, meaning by the solution matrix, this one. The answers you get will be X, Y, Z. That's how we use the inverse method. Exercise. Use inverse method to find X, Y, Z given X plus Y plus Z is equal to 2, X minus 3Y plus 2Z is equal to 7, 4X minus 2Y minus Z is equal to 9. Submit before here we have 10. Submit before 23 hours tomorrow. Since tomorrow we have no class, so you have from now up to tomorrow 23 hours to submit this task. If you don't submit, oh, it means you're up for a quarter. Box your actually. So I'm in serious business now. The exam is approaching, and no one should have an excuse. So do the work so that you understand these lessons. Have a good night, and please do the task as you follow up. Exactly. We want to have 100% pass record. So if you submit, we'll achieve that. If you don't submit, you make us fail to achieve that, which is a bad thing on your side. Okay, bye.